absolutely. Okay, so look, welcome everybody to this breakout session, and we're going to be talking about the Earth System Change Challenge, and we've got a panel here, and you can see them at the bottom of the screen. So myself, Andy Wheeler, Frank McDermott, Jean will be joining us, who's just given a talk in a minute. Lauren Scale, Louis Muzu, and Finbar Breton are all with us. And what we're going to do in this session is just give a short presentation to kind of explain the challenge. And we want to spend most of the time in discussion with you to sort of really work out how we can help you. So there's a couple of things up there. You're probably familiar now from the main session, but please put comments in the chat and we can look at those, and they can be very helpful. Because it's going to be a bit of a discussion, we really want to hear from you, really want you to perhaps join us on stage to ask questions. So you're welcome to post questions in the Q&A button. And if you want to actually join us on stage to pitch that question, then please do. And in the top right-hand side of the screen, you can request access to video, and then we can let you up on the stage. Okay. And that what we want to know in the discussion, we'll come back to this, is really how climate change is affecting your sector, what challenges you face, and how iCRAG can help you address those difficulties. So we'll just run through this short presentation and give you a heads up of what we're doing and set some context. And my first slide is really quite stark. And if it will advance, there we go. You can see there on the left-hand side, we have global temperature over the last 2,000 years. And on the right-hand side, we have human population and extinction rates over the last 200 years. Humanity is facing an unprecedented challenge in the history of its civilization. And we can't underestimate that. Our planet is heating, and it's heating rapidly because of the actions, because of the way we run our planet and our economies, and also the way we run Ireland. And not only is our planet heating up, but those activities are also causing extinctions of species and causing a biodiversity challenge. And climate change is only going to exacerbate that trend. And as geologists, when we look at these rates, when we look at these numbers, we realize that something very, very significant is happening here, and something very, very challenging is happening. And the planet is capable of doing quite massive climatic shifts once we reach certain tipping points. And we know that once that occurs, we end up with mass extinctions, and life will become rocky and very difficult for our society. So we need to change, we need to face this. And this is happening now, and it's happening in Ireland. And whether it's be through extreme flooding events or extreme weather events, or changes in our land use and our biodiversity, or an increase in natural hazards, or whether it's ocean warming, increasing jellyfish blooms, or whatever the manifestation of it, it's happening now, and we need to take action now. And iCRAG can help government and can help industry face these challenges and work out our adaptation strategies and mitigation strategies. And we can also try to work out what's going to happen, so we can anticipate how these challenges are going to manifest themselves. And that's what we're involved in. Now, our government and our world leaders are acting now, and they're putting out action plans, including the climate action plan and other kind of action plans that we all have to follow. And so change is happening, change is affecting our sector, and we are starting to adapt. And these changes in themselves cause certain challenges for certain industry sectors. So we're here, as I say, to try to help and assist, with government and with industry to face those challenges and to work at adaptation and mitigation, and also try to work out how things will manifest themselves. The kind of research that this involves is not directly applied research. it's not a one-to-one piece of research that generates a profit or a cost saving for a company. One of the insidious difficulties of climate change is it's incremental and pervasive, and it just sneaks up, but just gets worse. So it's the whole sector that needs to approach some of these challenges, and maybe collectively we need to come together to work out how to enact these. We have significant funding from SFI to do this kind of research, but we need buy-in from industry to help liberate those funds. And we want to discuss with you how to focus our efforts. Okay, so within the Earth System Change Challenge, we have the best experts in Ireland to address this challenge. And there's a number of them up there who have funded research that's ongoing at present, and others teed up to get started in the near future. And we've divided this challenge into climate environment through time, connected waters and Irish catchments, marine environment status and change and sustainability. And we're launching a new raft of funded projects around environmental geoscience. And with our Earth Science in Society sister challenge, we're also addressing public perception and risk in this talk because it's very, very relevant here. So what we'll do now is we'll go to through each of these themes, if you like, of this challenge, and just give an idea of the kinds of projects that's going on. So I'm going to hand over to Waymu, who's going to talk about some of the work going on under climate and environment through time. So over to you, Waymu.
Yes. So for the climate change and Earth through time challenge research theme, the scientific objectives will be achieved with the collective scientific expertise brought together by iCRAG, as well as through consultation and coordination with scientists and decision makers across Ireland. So the first scientific topic we are interested in is to improve understanding of the role of carbon, water, oxygen, and metal cycles during past climate crises. Here on the left, we see an example of the water cycle between the ocean, the land, and atmosphere. And it's also closely linked to the other cycles that we are interested in. And the second research topic is to link ancient carbon cycle perturbations to modern climate change. Here on the right, we see organic rich black shales being deposited during past super greenhouse climatic events in the geological past. And by better understanding the Earth system processes and feedback mechanisms will allow us to better understand modern day climate change. And the third research topic is carbon capture through enhanced chemical weathering. So our recent climate target of to reduce global warming by 1.5 degrees above pre-industrial levels requires us not only to reduce our carbon emissions, but also to actively take carbon out of the ocean atmosphere system. And for example, silicate weathering is an important carbon sink in the geological timescale. And if we can enhance such natural processes, which might act as a potential negative carbon emissions technology to mitigate climate change. And one of the approaches is to apply volcanic rocks, for example, as well as other industrial waste from mining, from construction to agricultural land, mediated by biological processes, can potentially sequester a lot of CO2. And the last research topic is to develop novel catchment-specific proxies to better understand elemental fluxes over seasonal to decadal timescales. This is closely linked to the previous research topics that I just talked about, but also to the other research themes in this Earth System Change Challenge.
Lawrence?
Yeah, hello everybody. I'm Lawrence Gill. I'm an environmental engineer based in Trinity College. So the broad aim of the research is really to characterise the full water cycle on a catchment basis, to give an integrated view of both kind of surface and groundwater, looking at water quantity issues, so floods, droughts, etc., and also water quality issues, so contaminant transport. These are of relevance to industries that use water as a resource, equally as relevant to environmental protection organisations and infrastructure, etc. So we have an experienced team of researchers across Ireland that cover a lot of different disciplines, so environmental science, engineering, hydrology, geochemistry, modelling, remote sensing, etc. And we've split broadly the research into 3 areas, so field studies, modelling and remote sensing. So in terms of the field studies, a lot of the researchers have long-term monitored catchments across the country which provide kind of characteristic Irish conditions. So for example, low permeability catchments in rural locations, karst-dominated systems, a variety of different wetland systems, bogs, fens, etc. And we also have a lot of collaborations with researchers overseas who have long-term monitored catchments, so ones in France, Slovenia, US, etc. We have, across the institutions, lots of different techniques of field monitoring, both the water quantity aspects and quality, and also a full suite of analytical facilities for traditional and emerging compounds, so inorganic, organic compounds, stable isotopes, etc. Then on the modelling side, next slide, yep. And so we got a lot of different experience at different approaches to modelling, some from sort of fairly standard hydrological modelling, 1D, 2D, 3D, using distributed or semi-distributed models. But increasingly, we've been using more kind of machine learning type approaches to characterize some of these kind of stochastic processes. We also use a lot of innovative numerical techniques to characterize flow paths through, for example, groundwater systems, as was proved in iCRAG1. And there's an increase in emphasis in iCRAG2 will be on the unsaturated zone, so this kind of living skin of the Earth where many of the key biogeochemical cycling processes go on. And of course, one of the reasons we producing these models is that we can make predictions for different climate change scenarios. So predictions of flooding, for example, more increased flooding in the winter or droughts in the summer. And these have been used, some of our models have been used in active projects that are being constructed at the moment. And then finally, on the remote sensing side, there's an increasing suite of satellite products available to monitor the water in environments, as well as drones, as you can see in the picture. And these have been used by different researchers in the iCRAG team to look at different differences in land use changes, which can be linked to hydrology, characterizing the health of vegetation, for example, in different wetland systems, or the extent of flooding. Yeah, so I'll leave it at that.
Okay. And on the marine environmental status change and sustainability projects, we have a number of projects, and some looking at mid-ocean conditions. So there's a lot of monitoring going on and modeling going on of changes in our oceans around Ireland. And what we need to do is try to integrate some of that data, and obviously working with the Marine Institute and others to try to pull these data streams, these monitoring efforts together, but also importantly to use machine learning to try to look at trends and try to look at relationships, so we can really get an understanding of how our oceans are changing and responding to climate change over many, many years. I was very pleased to see some of the comments in the chat about the AMOC, and we have a number of researchers looking at the AMOC and how that heats Ireland. If people are not familiar, you've probably heard of the North Atlantic Drift or Gulf Stream, which brings warm waters up to Ireland and really sets the temperature boundaries for our systems. And we're looking at how that changes, because it's climate sensitive, and changes in that have fundamental effects on European and Irish climate. We have a lot of projects looking at ocean carbon flux, including looking at carbon flux in the surface water. Obviously, we're quite afraid of carbon dioxide in our atmosphere. Most of that is absorbed by our oceans and stored in biological pumps. We're also very interested then in how that carbon translates down into deeper waters, where it could be held for hundreds of years rather than decades, and ultimately carbon flux into our sediments, in our shelf, in our coastal areas, and how that's also recycled and liberated due to various activities. And finally, we've got a number of projects looking at ocean noise, which is becoming a much more focused impact in our oceans, and we're starting to realize the significance of this. One thing we haven't got in Ireland is decent noise propagation models for all Irish seas. So we started to generate these so we can see how far noise travels and where it becomes focused. And you would have heard from Murray's talk, the work of Owen Daly on this. And we need to scale that up and develop that to an all-island basis. But also, we've collected lots and lots of data on ocean noise, and we're developing artificial intelligence to try to identify the different signals, the different noise events, and the different players, and try to triangulate those so we can understand what's happening in our oceans with respect to noise. Finbar.
Thanks, Andy. So my name is Finbar Brereton. I'm a social scientist and a lecturer in environmental policy at UCD. So individuals and communities can be exposed to different types of risk. And so we're interested in how to perceive the objective risk that they are exposed to. So that could be fluvial flooding, coastal flooding, it's already been mentioned, or other types of risk. And of course, these are increasing in the context of climate change. So there are different ways of measuring individual and community risk. So risk ladders have been used, and also cognitive mapping. So if you look at the top image on the screen in the middle, that's where individuals exposed to an objective risk have indicated what they believe to be the risk. So the risk perception. So the image on the top on the left is the objective risk, and then the on the far right is a collective community risk. So we can measure collective community risk as well. So using these methods, we're interested in measuring residual risk. So that's the risk that remains after engineered flood defenses have been put in place. And these are the images on the bottom where you can see the defense going in place. So people tend to overestimate the protection from built defenses. So there's elements of risk misperception. And so we're interested in how to communicate this risk to individuals and communities. So one size fits all approach to risk communication is not appropriate. So individuals' personal characteristics, past experiences of risk, influence how they perceive that risk, and of course react to risk communication. So our research is concerned with measuring risk perception and communicating objective risk appropriately to individuals and communities in the context of climate change. And as Andy said, it's linked to the societal engagement team in iCRAG.
Great, thank you. So just to kind of wrap up then, you got a flavor of the work that's ongoing and the work that we've developed and more to come. And you saw in an earlier slide the number of funded researchers with which we're growing. But we also have strong collaborations to draw on many other players in these projects, and many other players came together to craft these projects. So there's 62 expert scientists that to draw on, as well as the main team across the island of Ireland, in Europe, and also in North America. And as well as expertise and experts, we also have a lot of key facilities. Not all of them are shown here, but just examples. And on the left-hand side there, you can see field-based facilities, including flux towers, seismic sensors, elemental analyzers, so ways we can collect information and data in a range of settings, in terrestrial settings. And on the right-hand side then, you see equipment that we have to mobilize in the marine environment, including access to the National Marine Equipment Pool, including the ROV and the fleet of research vessels, as well as other equipment, including mini landers and OBSs, so we can monitor the environment and get data. And of course, we also have lab facilities. We have access to the National Centre for Isotope Geochemistry, that's an iCRAG facility, as well as a range of other high-spec, top-end, state-of-the-art analytical facilities in various labs. And by partnering with iCRAG, by collaborating with iCRAG, there's access agreements to this. So if you get involved in our research and get involved in our projects, then there's access agreements to this equipment as well for other kind of work, which is very, very useful. So I'm going to leave it there and just leave this summary slide that kind of encapsulates a lot of the work that's going on in the various realms we're working. But we want to turn the tables, really. We want to hear from you. We've said a little bit about what we're doing. What we're really keen to hear is how climate change and the climate action plan and adaptation is going to affect your sector. So what challenges do you think you're facing, and are there ways that we can do targeted research to assist you meet those challenges? So please feel free to put something in the chat, post some questions and answers, and we'll see what we can do, and we'll answer those. So please don't be shy.
Just a reminder, if you want to talk to everybody, just request to share audio and video, which is on the top right of your screen, and we will allow you on stage.
I'm good at painful silences. We really want to work out how to help people. So what challenges faces your sector? What do you see the threats? What do you need to know to move forward?
Or even if there is an additional comment on anything that's been presented or any specific questions to any of the members of the panel.
Someone must feel brave. There's 40 people out there. You don't want to hear me talk for another hour. Do any of the panelists want to make a comment to get the ball rolling?
I suppose a good question might be, is there anything that anyone thinks that we should be doing that we're not? Anything that we're missing that we haven't looked at? Or if people are very shy, you can start with a simple what you do to break the ice.
Okay, we actually have a couple of questions coming. So Chris Bean is asking, tell us about the upcoming marine project, please, Andy.
Okay, all right. Well, I can comment on that. We showed some of the projects there that are coming on stream, but perhaps to dive a little bit deeper and maybe to talk a little bit about noise. We mentioned that. One of the big challenges that we're facing in this country is our energy transition. And one of the solutions to that is offshore wind. There are a number of companies with big plans to build up a whole load of wind farms, and that generates noise. There's survey noise in trying to do the geophysics and do the seismics to have a look at subsea bed conditions. There's a lot of construction noise as well. So one of the things that we're doing at the moment is trying to put together a project called IMAP, where we partner with wind farm companies to try to look at this national noise propagation model. And one of the ways that we can do that is obviously in modeling in 3 dimensions, the water column and sound propagation. But we can also use advanced technologies that we've developed in iCRAG, such as fiber optic technologies to listen to noise, and different ways of trying to build up this picture of what's going on. And I mentioned some of Dias's work there of using artificial intelligence to listen to a lot of the noise records we've generated at present to try to identify events, whether they're vessel traffic, whether it's whales for that matter, or whether it's construction efforts. So there's a lot of work going on in that area, which is an exciting area that we're developing at present, particularly with the fiber optic technology, which is very new and has real potential to get very low cost noise records.
Okay, thank you, Andy. I'm going to let on stage Vincent OMalley to ask a question or a comment. Yes. Good evening, Vincent.
Good evening, or it is evening actually, it's just getting in there. And thanks for the presentation. I'm particularly interested in Finbar's work on the perception of risk And I'd like to know, like, how is he actually scaling risk from local to global, and how can he separate out the noise between the two? It would be
Thanks, Vincent. Yeah, that's a really interesting question. How people perceive risk is it's kind of similar, depending like the type of risk that people are exposed to. Like even during, say, for example, the coronavirus epidemic, people tended to underestimate the risk unless they'd been exposed to it, had experience of it. So that's when I mentioned in terms of people's experience, personal characteristics. These are really, really important dimensions in terms of risk perception. I mean, I'm not sure the approaches we're using in terms of, say, cognitive mapping. I don't think perhaps you could get individuals to indicate on a global map where they believe climate change will impact most. It tends not to be where you live. It tends not to be in your locality. It tends to be in future times from when you are, particularly in the Western world. And this is why, of course, people tend to be slow to reacting to the risks of climate change because they believe they're far away, either spatially or temporally. Not sure that answers your question particularly well.
Yeah, maybe I should have introduced who I was. Yes, I'm Vincent OMalley, and I'm head of the Environmental Policy and Compliance section with Transport Infrastructure Ireland. And we have lots of commitments around decarbonisation and adaptation with regards to climate change. But then we have also issues around the risks from like noise would be generate a risk to people, and the local risk, and we're looking at a lot of those response curves and how people perceive risk at a local level, and then you add the climate elements on top of that, and where does the noise start? How do you decipher what is the biggest impact for them, or how people are perceiving that particular impact? So
yeah, I mean, it's interesting. I was at a virtual conference quite recently, where what are the biggest environmental issues in Malta came up, and one of the issues that was suggested was dog poo on streets. That this was coming up in respondent survey. Now, of course, dog poo on the street, while being annoying, is certainly not of a catastrophic nature in terms of climate change. So people tend to underestimate the risk on the normal curve when you get into those catastrophic, the big tails. So they tend to focus on that type of risk while almost pushing aside things in the everyday. So people will happily drive while drunk sometimes, but yet they won't get on a plane. So it's the risk, the risk from these different factors is completely different. I mean, it's I've done quite a bit of research on, for example, the impacts of noise on subjective well-being, happiness, life satisfaction. So noise, other environmental issues in an area. Again, people tend to trade off. So they're willing to put up with certain environmental disamenities such as noise, etc., for other benefits such as being closer to facility services in a city. So there are trade-offs, and people accept that there's trade-offs in, for example, living in a city compared to living in a rural area. I mean, it's certainly an interesting one, and I would be certainly willing to discuss more in terms of what we could potentially do for your organization in that area.
Okay, thanks, Phil. That's great.
There's going to be a networking opportunity later at the end of the session. If you guys want to join spatial chat and continue the conversation. Okay. Thank you, Vincent.
Thank you.
I'm going to add on stage Mary Curley.
Hi, how are you? I'm Mary Curley from Met Éireann. I work as a climatologist. The area I would be interested in is actually communicating climate change to people, getting the narrative right. And we do see in our organization the need for, social science, etc., to get the tone right for, getting the message across so that people actually listen, and you're not scaring them, but it's actually, relevant to them. And I was just wondering, has there been any projects looking at that so far?
But do you want to answer that?
Yeah. I mean, I guess it's again, it's a difficult one in terms of communicating the risks, obviously, from climate change. I mean, there's research around the psychological, the psychology of climate change, and as I mentioned, in terms of those spatial and temporal disassociations from climate change. We have a colleague here in UCD, Cara Augustenberg, and she has a radio show with News Talk. She has a Twitter feed, so she's quite prominent in terms of communicating climate issues to the general public. It's I mean, the mismatch between what the science says in terms of the people here today and what we believe, the impacts of humans on the climate system is unequivocal according to the IPCC. Whereas when you get down, when you ask the general public, they're not so sure we know what we're talking about, because social media, even quite recently, there was a study showing that the issues around climate change can be dominated by topical issues such as veganism, vegetarianism, when all the other things are kind of put to the side. There was a recent study showing again that people tend to focus on the smaller items. So reusing your coffee cup, turning off the lights, issues that are kind of simple for people to do and easy for them to do, but avoiding the bigger issues like not flying, having less children, that really impact on the climate system. So I'm not too sure we want to get into communicating to people to have less children. That might be politically unacceptable. But there's the bigger issues that potentially need to be communicated better to people. I do believe a one-size-fits-all doesn't work, but we need targeted campaigns to capture people. So you've got people who A, don't believe climate change is happening, B, who believe it's happening but it's not human driven, and then you have people who believe it's happening, it's human driven, but aren't willing to change their behaviors, i.e. Increase taxes, etc. So you have a different cohort, lots of different cohorts of people, and that need to be individually targeted, and it's determining who they are and identifying them is the issue.
Okay, thank you, Mary. Thank you, Finbar. There is a question from Owen Brody. You have described a set of challenges across a broad range of temporal and spatial scales. Are you working to bridge these scales through multi-scale modeling, for example?
I can take that one if you want.
Thank you, Lawrence.
So, we'll just give you an example. One of the few projects that started actually on the water side is a project so there's a Professor Jenny McElwain, she's Professor Botany in Trinity, and then it's between her and me, who I look more on the sort of hydrological side. So we're focusing on evapotranspiration as a process, and so she focuses very much on the individual plant scale, and I focus very much on the sort of catchment scale. And it's a big kind of level of uncertainty in hydrological modelling how much evapotranspiration goes in terms of the whole water budget. And so in engineering approaches, we have quite coarse ways of assessing this, across time, across different seasons, how vegetation, how much water they pump up to the atmosphere. Jenny looks at the individual plants on a sort of physiological perspective, but she also, very instantly, she goes back hundreds of thousands, millions of years, looking at plants going back that time and how they respond to different climates in the past, different carbon dioxide levels particularly. So what we're doing, we have a new 4-year project where we're looking at, she has controlled labs where she can control temperature, light and carbon dioxide levels, and we're growing different plant species and quantifying the evapotranspiration on individual plants. So that's going to be modeled, and then also looking at fossils of plants going back in time to look at how they've changed in terms of the stomata and therefore how much water vapor they emit. So that's very controlled on a lab scale. Then we have these so-called mesocosm scales. So I do a lot of research on wastewater treatment, like passive treatment systems, which very controlled water budgets. So we have a pretty good idea, like the size of a field, for example, how much water is being evapotranspired, and also on wetland systems. And then we have large scale catchments that we've been modeling for many years, where we can try to characterize the evapotranspiration. So the idea is to come at it from 2 different perspectives and develop better modeling tools by which we can predict evapotranspiration across time, and then also make predictions into the future with rising CO2 levels and different temperatures. So that project is just, we've just appointed a person actually yesterday, and we'll be starting in January. So it's quite an exciting project.
I can maybe contribute to that a little bit as well. So to answer Owen's question about multi-scale modeling and so on, some of the work we're doing on enhanced weathering, for example, essentially enables us to, well, requires us actually to integrate the results from a plot scale to a field scale to a catchment scale, and then to trace the solutes all the way out to the ocean, because we want to make sure that the solutes that we're weathering during the enhanced weathering process actually make it all the way out to the ocean, where they might precipitate limestone, for example. So again, that's another example of where we have to essentially scale up and integrate between the scales, as Owen just alluded to there.
Okay, Jenny made a comment there about microplastics and whether there's any microplastic research been done in iCRAG, and Lawrence was mentioning there about groundwater systems.
Yeah,
you might want to come in there, Lawrence.
Yeah,
several of us are also involved in other research projects outside of iCRAG, and I have a postdoc, Alicia, working on microplastics in deep water environments and cold water corals. We certainly have the capacity to sample microplastics and then use FTIR to work out which kind of plastics they are and where they're occurring near shore and in the deeper ocean. Lawrence, do you want to talk about groundwater?
Yeah, so actually in iCRAG1 we had a PhD student who's, I think he's in the audience actually, Luca, who was investigating a variety of different contaminants from karst springs, and he looked at microplastics using FTIR as well, and characterized that. There's been a follow-on from that. There's going to be a European characterization of microplastics in groundwater being led by a UK university, and we're taking part in that. So we're going to resample some of the springs to add to that database. I'm actually involved in an EU art science collaboration as well, which is a bit wacky, with an artist in Berlin, which is, the theme is microplastics. So we're looking at a variety of different ways. So we're writing this story effectively about as if plastics had developed from fungi millions of years ago, and we find them in the rock. It's all a bit and we're composing this piece of music. It's all about, anyway, increasing the perception of how people look at microplastics and the fact that they're going to be around for a long time in the environment. And so that's an ongoing art science collaboration.
Jean, do you want to comment on that question in the chat?
No, just got an email there from a colleague saying they can't access the Q&A, so he just emailed it on to me. So Ken Byrne in University of Limerick, who's, I suppose, an expert in peatlands and carbon, has asked, would catchment level monitoring, modelling of hydrology, which we all do really, or a lot of us do, useful to understand the feasibility of rewetting at this scale and overlap with other land uses? So maybe Frank or Lawrence.
So just wondering what Ken, when he says at a catchment level, I mean, certainly understanding the hydrology of rewetting peat bogs, it means like we are involved in that. We say rewetting. Rewetting. I can't really speak to him directly. Do you mean going from a kind of peat bog type scale up to a wider catchment level?
I think that's what he meant.
Okay. I mean, I think that definitely. So one quite significant thing that's been understood, I think, over the last 10 years for raised bogs in the middle of Ireland is, the traditional view of them was that they were kind of isolated, just fed by rainfall, and fairly isolated from the rest of the catchment around them. And a lot of work was done in Clara Bog, actually, has shown no, there is a significant interaction with the groundwater system underneath hydrostatically. You might not be getting flows of water coming up into the bog, but it's the pressures holding the water level up in the bog. And so a lot of these bogs that have been harvested now, well, first of all, there's probably that interaction anyway, and then by removing some of the marl, it's created a much more intimate connection with the surrounding catchment. And so by rewetting, you can't look at the bog in isolation, basically, is what I'm saying. And so you have to work out what flows are coming from the groundwater into the bog. So there's some of these bogs along the Shannon. I mean, they're basically just going to flood, and they are flooding all the time unless they're being pumped out, because they're just in direct connection with the Shannon and the groundwater system. So, you know, unless you take that into account, you're not going to be able to successfully re-wet these to get that perfect, balance that you need to get the sphagnum growing. So yes, I think if that's what you mean, you definitely need to understand much wider than the individual at bog level to understand how this is going to be successful. It's re-wetting.
Maybe just add to that as well, that we also need to understand how the hydrology and changes to the hydrology will influence the gas fluxes, greenhouse gas fluxes, on rewetting. For example, what the impact might be on methane, or let's say on methane or CO2 evasion from surface waters. So we need to integrate the gas side with the water side, and that's one of the kind of objectives and aims of iCRAG2.
Thank you all. There was a follow-up comment from Owen Brody again. I'm not sure if he has been read because I froze for a little while. He was wondering if you're bringing this multi-scale approach to develop decision support tools. I don't know who wants to take that.
I mean, from my perspective, certainly work I've done in the past on contaminant modelling and in catchments, we've developed decision support tools. So, for example, if the evapotranspiration, if we get better insights into that, then that naturally would feed into those tools, as a part of the overall modelling process, I guess. If that's what you mean.
So to add to that, some of the projects I've been working on by looking at super greenhouse climate happening in the geological past, which is often associated with a large amount of greenhouse gas emissions from natural processes like volcanism or methane hydrate destabilization. And the way to track that is, for example, to look at the stable carbon isotopes. And because methane, biogenic or thermogenic methane have very distinct carbon isotope values, and as well as a volcanic carbon dioxide. So if we measure the carbon isotope composition of the sediment or specific organic matter through time, and we can see how the changes of the different fluxes, carbon fluxes, either through volcanism or through methane sources, are changing through time. So that's another way to look at it.
Thank you. So if we move on, there is a question from Michelle McEwen. She says, just a follow-up. She says, fantastic session, first of all. Just a follow-up question to the rewetting question. We can use peatlands to reconstruct past hydrological conditions. Is anyone looking at ways to reconstruct carbon and methane fluxes through time?
I think that's a very interesting question, actually. I'm not so sure we were planning that, but I think as a concept, it's very interesting. And it would, like the person I talked about, Jenny McElwain, she certainly looks back at vegetation through time and reconstructs kind of, with the aim of reconstructing climates, etc. So, yeah, the idea of reconstructing past hydrological conditions, there is, to an extent, is being looked at. But then the next step to reconstruct carbon and methane fluxes, I'm not so sure. I mean, Ken Byrne actually would probably be the best person if he can get access to the chat to answer that one.
Yeah, I think it's it's not clear what proxies one would use to reconstruct fluxes at the scale of an individual catchment or peat bog or whatever in the past, because there's no obvious kind of recorder of gas fluxes directly. I mean, I think on a larger scale, one could possibly, look at models and construct models based on what we know about current systems, and then run them backwards to see what the fluxes might be. But I think it's tough to reconstruct, gas fluxes because of the lack of a recorder, a proxy.
We have Michelle on stage now with us.
Sorry, I thought I'd join in and say hello.
Yeah, that's a good move.
Thanks, Lauren and Frank, Lawrence and Frank. Sorry, a bit of a cold, so excuse my very husky voice today. So I'm aware that there's some work in Switzerland that are actually developing a proxy for doing this. You can develop an inference model. You can use it alongside paleohydrology, like inference model as well. And that works very much in the early stages, but they have some really interesting results. But they're only applying it in Swiss peatlands. So I thought it'd be really interesting to do something similar in Irish peatlands as well. This will be so important because with this rewetting, we're rewetting because we want to get the water tables higher so we can store more carbon. We can have a look back in time as well and get an idea of like using these two proxies together, and might be able to show kind of maybe ways to optimize maybe that kind of
I mean, so it's only work we and other people have been doing over the last few years on bogs in a variety of different conditions, intact bogs and degraded bogs. We've been looking at fluxes, carbon dioxide and methane fluxes, particularly under these different, from, they're just perfect stagnant kind of side down to more and more degraded. So that gives you differences, which is very linked to the hydrology. And so from that, you could probably back calculate from the nature of the heat, what the hydrology was, and therefore you look at this gradation of systems that we have now, and we get much better ideas as to how much flux comes from these different hydrological conditions now, and maybe do some back calculations that way. That could be very interesting. But there's a lot of projects now going on across Ireland on peatlands in a variety of different stages of degradation and the whole rewetting thing. There was a conference a few weeks ago, the Peatlands Gathering, which kind of gathered all different people across Ireland to talk about all this, etc. And yeah, it's really interesting time at the moment for peatland research, I think.
Yeah, no, definitely. It's a fantastic time. Sorry, I'm originally from Ireland, but I forgot to introduce myself. Sorry, I'm Michelle McCall. I'm a lecturer in environmental science in the School of Biological and Environmental Science at UCC. So I work with Andy and Jean.
Okay.
So I've just arrived after spending 7 years away from Ireland. So I'm still trying to, figure out what work's been going on and, see who's been doing what. Yeah, so this is fantastic. Thank you.
I think it's a really important topic because, rewetting is seen as a solution, but actually there could be unintended consequences, as you say, Michelle, and we need to understand those a lot better, I think. Otherwise as well.
Sorry. I think it's exactly, there's definitely going to be a big methane flux when you first rewet these bogs, but it's in the longer term, of course, they start taking carbon, but it's inevitable. I think there's this big release of methane.
Yeah, because they're rain fed as well. We have to understand the climate dynamics as well with rewetting as well. So it becomes like quite complicated, but quite an interesting area as well.
Frank, on this, there is a question for you. Are you looking at gas fluxes under prolonged drought condition? From Vincent.
Yes, it depends really what you mean by prolonged drought, I guess. Certainly on seasonal scales, we're getting to the point where we're starting to be able to monitor gas fluxes. It's one of the ambitions of the project we're starting at the moment to monitor gas fluxes from soils, especially amended soils, and we'll be doing that on a sort of seasonal, month-by-month basis. So we will see, what might happen during drier periods. So in the Irish context, the drought, might just be a couple of dry months in the summer time, I guess. So I'm not quite sure if that's what you mean by drought. Or do you mean a very, much longer kind of dry period in maybe a more arid climate? It's an important question.
Maybe I could ask a bit of a question to the audience. And it's, well, we have a new project starting looking at carbon flux in the ocean, and particularly the impact of trawling on remobilizing carbon. So when you trawl the seabed, you release a lot of the carbon that's been stored in the seabed, and it becomes available again in the environment. A lot of that carbon transfers across the shelf into the deep ocean, where it becomes a food source, but maybe not the best food source, because it's relatively old carbon, and some of the more nutritious parts of it have gone. So we have a project where we're going to listen for trawling activity with some of these noise sensors, and then we're going to sample these trawling plumes across the shelf and into the deep ocean to try to capture the amount of carbon that's liberated and the quality of that carbon. One of the difficulties with that kind of project is liberating funding and finding an industry partner. And this is kind of quite typical of a lot of some of our research. There's really important questions that we need to know to help Ireland, to help society, but are not directly applicable to an industry partner. And I wonder if people out there have any suggestions about how industry could get involved with some of these very relevant and very important projects, but may not be directly applicable to their industry. Are there any ideas or thoughts in terms of pooling funds or philanthropy or any other models that people are aware of? Because it's a challenge for us to get this research to happen. I'm not asking you to put your hand in your pocket, just asking for ideas.
Yeah, it might be just worth saying that the SFI funding model relies on co-funding by industry. So industry contributions, let's say, or philanthropic donations are necessary to basically release the SFI funding.
So Andy, I just put a slide there with contact details in iCRAG if anybody's interested in funding opportunity or projects in collaboration, and we can explore funding opportunities also from national and international funding agencies as well as appropriate to the project. I don't want to cut this discussion short, but the Bob Watson, Sir Bob Watson keynote access is starting on the main stage. So feel free to remain on the panel if there is any other question, but if anybody wants to join the conversation, you just have to press stage on the left-hand side of the screen. There is a comment from Owen, the Moore Foundation would seem relevant, Andy.
Okay, great. We'll have a look at that. Thank you very much.
I'll have a look at it, yeah. Okay, so I'd like to thank everybody in the panel and everybody in the audience who participated into the discussion. So as I said, if you press stage on the left-hand side, you'll go back on the main session, and there is Sir Bob Watson address at the moment. And there is, at the end of the whole event, there is a networking opportunity, a chat space on spatial chat, and they will give us the instructions on how to join at the end. Thank you all.
Thank you, everybody.
Thanks all.